Right or left? Which one do you think's harder? I think the right as well, right? So here, we'll start with the right side. The right side, we're going to get sine. Can't write to it. Sorry. Yeah, if you're not done, bring it up. Sorry. Underneath. Sorry. Okay. Oof, what are we gonna do here?
Yeah, make the 1 cos squared x over cos squared x.
I wasn't listening. I was thinking to myself.
The 1 cos squared x over cos squared x.
Make the 1.
Inside
Oh,
the bracket.
inside the bracket. Oh, I see. You want to turn this into something?
What? The 1. The 1 plus.
Oh, I see. Use the terminology common denominator. Create a common denominator. Is that what you're saying?
Yeah.
Okay. It's descriptive. Then I know what you're saying. So we get sine squared x multiplied by cos squared x over cos squared x plus sine squared x over cos squared x. Okay? Now you've got a common denominator there, right? And I can get sine squared x multiplied by cos squared x plus sine squared x divided by cos squared x. Which then simplifies to, and if you don't need to write all this, don't write it down. You could write parts and pieces, whatever you need, okay? Cos squared x plus sine squared x turns into 1 over cos squared x. And then when I'm multiplying fractions, I get sine squared x over cos squared x. And I'm going to stop there. And I'm going to jump to the left side now. The left side's an easy one, right? Because you've already actually kind of done that identity in this question already. So it's just going to turn into sine squared x over cos squared x. So therefore, left side equals right side. We okay? Okay, let's go next one. Similar. Is everyone good with question A? Okay, question B is similar, albeit not the same. It's very close. Similar. Okay, same sort of approach, I think, actually. So if I just, what do you want to start with, left side or right side?
Right side.
Bryce, did you say left side? Okay. So let's start with the right side. The right side, cos squared x minus sine squared x. Is there anything I could switch in there?
Sine squared x can switch for minus 1 minus cos squared x.
Yeah, again, like you're seeing that cos squared x on the left, so I'm going to try and get rid of the sines and just only have cosines on the right, right? Because remember, this is a balancing game. It doesn't make sense to have 2 different things if you've only got one thing on the left, right? So let's just try and switch the using the identity sine squared x into coses so that I only have coses in the question, right? So sine squared x, just be careful with the treatment of this negative. Okay, it's minus whatever sine squared x is equal to. Okay, no, that's gonna get some people. You make a substitution, it's gotta go in brackets, right? I've talked about that a number of times in this course. Doesn't matter if it's in like an integer you're making an input for, like in function notation, or if it's actually like a substitution like what we're doing here, right? You make a substitution, put it in brackets, because if you don't, you're gonna get, if those brackets weren't there, what would you get?
-1.
You just get -1 because the cosines, cos squared x is like 0 pair out, right? Which would be your first clue, right? So you got to put the brackets around the substitution for sine squared x. At which point you can distribute the -1 in, and you'll get cos squared x minus 1 plus cos squared x. And so we get 2 cos squared x's minus 1. And so therefore, left side equals right side. Okay, I don't know how C is going to go yet. It's the first time I'm looking at it, so we'll just see. Okay, once everybody's good with B, we'll go down, scroll down, and you can tell me what side you want to start with and see. Okay, is everybody okay? Go down as you see. Left side, right side, what do you think? Again, it doesn't matter. You're gonna, if you start with the, sometimes you're gonna have to do work on both sides anyways, it doesn't matter. Yeah.
Can we start with the right side?
Gabe wants to start with the right side. Are we okay? I don't know. We can start with the right side. That's okay. Okay. Again, we might have to. I see it. Listen, the reality is I see tan x on both sides. So I think we're gonna have work to do on both sides regardless. Okay, because I see tangents and I don't really want to work with tans, right? So on the right side, I get 1 plus sine x over tan x. And I know tangent is sine x over cos x. And so subsequently I have fractions inside of fractions, and to deal with that, particularly in the denominator, I can take the denominator, bring it up and multiply by the reciprocal, right? So I'm going to get 1 plus sine x all multiplied by, and again this might be something that gets some people, I'm not sure, cos x by sine x. Okay. Everybody okay? We'll see what we get here. So I'm just going to multiply this out. And I'm going to get cos x by sine x. Oh, yeah, that's okay. Plus cos x sine x by sine x. Okay, I'm going to stop there because I don't know if we're going to necessarily get much more out of that. Are we okay? All right. That was also maybe just, I don't know if that was the greatest move, but anyway, we'll see. I just took, I took 1 times the fraction, and then I took sine x times the fraction. I don't know how informative that little move was. I think we should do some work to the left side. Okay, so let's jump over now. I get cos x plus 1 over tan I'm gonna get cos x plus 1 over sine x over cos x. And so I'm basically gonna get cos x plus cos x by sine x. Okay. Can I add those two things together currently? No, so what do I need? You need a common denominator between the two fractions, okay? So the common denominator, if I've got cos is over 1, then I can multiply that fraction on the left by sine x by sine x, because that's the piece I'm missing. And so I'm going to get, in the next line, should get sine x cos x by sine x plus cos x by sine x. I guess that wasn't too bad.
Can't you like cancel?
If you, the reason why I'm saying this was I don't know how informative that was is because I could technically just divide those out, and then I'm just kind of left with, yeah, doesn't matter. The left side equals the right side. We're happy, right? Wasn't bad, but okay. Is everybody okay?